Your accessory organs, if you don't remember what those are, remember accessory like jewelry or accessory. They're not actual clothing that you need to have, but they definitely make everything better, right? Same thing with your intestines. The same thing with your internal organs. Your accessory organs are not actually touching the food. They're not actually doing any of the physical breakdown work, but they are going to make everything better. Right? These are your accessory organs. Shown here uh, is your liver. So, by the way, this is your stomach, esophagus, stomach, and small intestine. Those are not accessory organs. I just put it there so you understand placement. This is your liver. And then behind your liver, you see the green. Out of order there. You can get rid of the stomach. There we go. The yellow here is your pancreas. And then this big thing is your liver. And then behind that liver is your gallbladder. Right? The liver and the gallbladder are going to work together. That's why they're overlapping each other. The liver is going to make a chemical that when we're not ready to use it yet, we're going to store it in the gallbladder. So let's break these things down. Again, just for, I already said it. Here it is for the notes. Accessory organs are things the food never actually touches. Instead of handling the food themselves, they are going to create chemicals that cause digestion to happen. These things are glands. We talked about glands before, so quick refresher. A gland is just a clump of cells. Remembering Bio 1, we learned cells undergo protein synthesis, meaning they take amino acids and they make proteins. All right? This is a clump of cells. Every single cell in this pancreas is undergoing protein synthesis. It is taking amino acids and it's making a very specific protein. In this case, these proteins are going to be used to make digestive chemicals. Right? And then those digestive chemicals pour out into the intestines. Right? So they make it in here, they pour it into this duct, it then travels into the duodenum that I already mentioned, and that's going to help you digest your food even better. Where is your pancreas? It is located posterior to the stomach. If you don't remember that terminology, it means behind. It is behind your stomach. It is going to make that pancreatic juice. I know it doesn't sound very scientific, but that's actually what it's called, pancreatic juice. Right? Going to break down carbohydrates very well, which is great because you already had a head start with that with the amylase in your mouth. While pancreatic juices also contain amylase. It's also going to help you break down fats, which are very hard to do, and the liver is going to help out with that. We'll get back to that in a second. And it is going to do a fantastic job of breaking proteins down into those amino acids because, as we just said, protein synthesis. We need amino acids to make our own proteins. You eat cow proteins in a hamburger, break them down to amino acids with the pancreatic juice, and then use those amino acids later on to build your own body. The pancreatic duct, it is this tube traveling the inside of the pancreas. So as all the cells in the pancreas are making the chemicals, they all drain into this tube, which then pours out into the intestines. And that liquid is going to move around the entirety of the small intestine along with the chyme that made its way in there, and they're all moving together. All of that's going to help us break chemicals down even smaller so that we can absorb it into the bloodstream. Remember, not shown in this picture is your blood vessels are surrounding these intestines. It is absorbing all the good nutrients. We will get back to that in a different video. Liver, located in the upper part of the abdominal cavity, meaning right next to the stomach, just underneath the lungs. Now, this is a different gland that is making different chemicals. It has a whole bunch of jobs, right? It says don't write this, right? Because this stuff isn't going to be tested on. This is non-digestive things that your liver does. Still food-based. It's just not it's not part of digestion technically. Helps metabolize carbs into proteins, meaning, metabolize carbs and proteins, meaning we're going to break the carbs down and turn them into other things. It's going to help with that. It's going to help make fats. a lot of the fat molecules that you're going to use to store stuff in is there. We're going to use the liver for storage. A lot of you already know it cleans alcohol out of the body, out of their blood. It's not a filter like your kidneys. All right, your kidneys take stuff out of your blood and put it into your urine. You pee it away. Your liver has no connection to your bladder. Does has nothing to do with pee. Instead, it's going to take this alcohol, which is poison, and turn it into a sugar, which is not poison. Right? So it keeps us alive in that sense. None of these are actually digestion though. So what is this going to do with digestion? It is going to create another chemical. Remember, it's a gland, a pile of cells that are going through protein synthesis. And all of those chemicals are going to be going into this duct and either into your intestines, or if you don't have food there, going to get stored in the gallbladder, as shown in this animation. Now, I'll show you a little something special. This, ladies and gentlemen, is a liver. This is a liver from a deer. This was given to me by Mr. Gallagher. I told him I was interested in trying deer liver. He saved one for me. If you have him this year, he's probably shown you a picture of the deer it came from. Right? Because this is directly attached to your bloodstream. Because remember, all those other things I showed you, there it's taking things directly out of your blood. There's a lot of blood inside of this thing. This was very, very messy. I had to do a lot of work to clean it out. And when I cut it into slices, you can see all these holes in here. Let me zoom in for those of you who are on phones. See all those holes and gaps. Those are a combination of blood vessels or bile ducts, right? Some of them are, I believe this right here is a blood vessel. It's very messy, right? A lot of blood is going in. It gets absorbed, gets changed. At least the alcohol gets changed into sugar and things like that. But also, all of this meaty looking material is not actually meat, just cells upon cells going through protein synthesis, creating bile, a green liquid that we talked about in the vocab, right? I'll show you that in a little bit too. That bile is going to make its way into these ducts and then travel out of the liver into the gallbladder. Oh, here's another good picture of the ducts being able to collect stuff and move it. You see it looks kind of like a funnel, and it's going to all filter in there. So again, those openings you saw, that's what these are. These are the ducts, and all the liver, all the bile stores in this gallbladder. What that stuff is bile, the yellowish green liquid that your liver secretes. Now, this is going to be a really gross description, but it's the only way I can think of it. You would have experienced it. Have you ever thrown up so bad that you ran out of throw up? Yeah, like you're really sick and you're throwing up and then there's nothing left, but your body's still trying to throw up even though nothing's coming out. Eventually, this really bitter, gross, greenish liquid stuff comes out. That's bile. It's not supposed to come out there, right? It's not even, that means it went through your stomach. It's never supposed to go through your stomach. It's supposed to go the other direction. So, but that's what bile is. You probably experienced it. What it does is it helps you break down fatty stuff. So it's going to travel through, it's called the common bile duct. So your liver is up here, and if you don't need it, it gets stored in here in your gallbladder. But if you do need it, it's going to continue and meet up with the pancreatic duct. So they're the same connection. They're going to have the same entrance into your small intestine. So now you have both liquids flooding your intestines as the chyme enters from your stomach. Both of these things are going to break stuff down. The pancreatic juice is going to break down the molecules. The bile, on the other hand, is more of a physical breakdown. You know, it's not actually chemically breaking anything down. It is making fat globs from the food you eat even smaller so that the pancreatic juice can get to it. We call that emulsifying. It emulsifies fat. The breakdown of fat globs into smaller globs. So here is a big glob of fatty goodness, right? You just swallow that. So you just left your stomach into your intestines. It's in your duodenum. And you fill that with bile. And then it didn't dissolve away, not like the metal tab in the acid, right? It's still there. It's just spread out. Now the pancreatic juices has the ability to get in between and really break it down. I showed you a real video of that happening back in the vocab. Right, so here is actually a chicken liver. It's kind of cut up because the person was trying to get to the gallbladder. When the gallbladder is attached to the liver, they got this loading. But this person got chicken liver. All right, my voice. So this person got chicken liver, found the gallbladder filled with bile. Yeah, I'm actually showing you my old video. I got my old video in this video, so I got videoception happening. Let me see if I fast forward on the right thing. All right, this person drained it out, filled it up in here, and mixed it with oil and water. And if you remember, after stirring it up, stirring it actually emulsified it too. You turn the fat glob, remember oil is fat, it turned the oily fat globs into smaller globs. But, fast forward a bit, there we go. You see that left to its own devices, those fat globs start coming back and become bigger fat globs, where with the bile, it keeps it separate into smaller fat globs where the pancreatic juices can get all in between and break them down even more. Moving on. So what is the gallbladder itself? It is this pear-shaped sac attached to the liver, and it stores extra bile. Right? If you're not currently using it, you don't want to waste it because this stuff isn't made very quickly. Remember, your liver is busy doing a whole bunch of other stuff. So this is a slow process of building it. And the more you have, the more fat you're able to emulsify. So it's good to hold on to it. When you do need it, it's going to get released and mix in with the food and emulsify all the fattiness. Nice and easy. All right, a little extra information. This is not going to be tested on, but people always ask me about this. Having your gallbladder removed. This is a word that I never pronounce correctly. And even when I do, I forget what I did. So cholecystectomy. Nope, I missed that. Cholecystectomy. See, always get it wrong.
Cholecystectomy.
But this is a gallbladder removal surgery because some people get gallstones, meaning the bile inside calcifies. It gets mixed with calcium and becomes solid and then can't move, and it's stuck in there. And the doctor can't fix that. They just have to remove the gallbladder altogether. We call the calcified bile gallstones. It blocks the flow and things can't move. This is a real gallbladder, by the way, filled with real gallstones. Those are not as soft as they look. They look like peas. They would actually be very solid and painful. You can actually survive without the gallbladder, by the way. It just means you can't store the bile. And since making bile is a slow process, instead of storing it, we're only going to get a little bit at a time, and it would just go right into your intestines. So when you do swallow the food, it's not going to be a lot of bile, not a lot of emulsifying. Digestion is still going to happen. It's just not going to be as easy. All right. And that is it for the accessory organs. In the next video, we will move into the intestines. I understand there's a lot of videos. Your digestive system is a lot of stuff. All right. So for now, go to Google Classroom and look for the assignment. Good luck.